Hey guys, welcome to Unit 1, Lesson 1, Part 2. And we're going to really get into some new things today. And the first thing that I want to talk about is standard position. So in trig, we don't only have an angle. A lot of times it's attached to the coordinate plane. So in that position, your vertex is going to be at the origin. And this is going to be your initial side. So those are your two fill-ins. Your terminal side is going to determine your angle measure, and we've kind of talked about that before. So if your vertex is at the origin and your initial side is here, and your terminal side is over here, then that would be considered in quadrant 2 for your angle measurement. The next thing I want to talk about is quadrantal angles. So these are the angles that land on the x or y axis. And those are kind of also a big deal in trigonometry. The third thing I want to talk about is coterminal angles. So the goal a lot of times is if you have an angle that's too big, we need to get it between 0 and 360 degrees, because that will get us on our somewhere on our coordinate plane within, so we can tell like which quadrant it's in and things like that. So that's usually our goal. There's an infinite amount of coterminal angles, and we'll kind of talk about that in a second. So the measures of coterminal angles differ by a multiple of 360. So every rotation is going to be a new coterminal angle. So let's kind of put this into practice. We need to find, so we have this angle that's negative 75 degrees. So first of all, let's kind of think about what that would look like. So this is our initial side and our vertex. And so our terminal side, we're going in this direction because it's negative. And so this is going to be negative 75 degrees. So if you have something that's not between 0 and 360, or you just want to find another coterminal angle, what I'm going to do is I'm either going to add or subtract, depending on what I want, to give me another coterminal angle. Again, so keep in mind that there's an infinite amount of coterminal angles. So we have 360 plus negative 75 is 285. So what this would look like for our example is this angle right here is 285 degrees. So these are both coterminal of each other. We can also take negative 75 and subtract 360 degrees. So what that's going to do is that's going to give me another rotation in the negative realm. So it's going to look like that. And we can keep going on and on forever. So every single time you have a new coterminal angle, it's going to differ by 360 degrees. So theta is going to be your angle measurement. Theta is going to be used a lot in trig. It's just like a variable. So theta plus or minus 360 degrees n, and n is our rotation. And that is going to be a generic form to figure out those coterminal angles. So let's go down to B. So I want the least positive measure coterminal with 908 degrees. So I'm going to take 908 degrees and I'm going to subtract 360 from it. Okay, so I ended up getting 548 degrees, but that's still too big. It's not between 0 and 360. So I'm going to subtract 360 degrees again, and I end up getting 188 degrees. So what this tells me is that it's going to end up in the third quadrant, and it's going to look like 188 degrees. But the difference between 188 and 908 is that it has two rotations in there. There's 360, there's 720, and then there's that 908 degrees. So it differs by the amount of rotations it has. Okay, so what I want you to do is I want you to find the angle of least positive measure, coterminal. So this, when you see that, that means between 0 and 360. So go ahead and do that. Okay, so what's important to know about coterminal angles is that they're going to look the same. So for instance, if I had this might be a 45-degree angle, or I might go all the way around and it is now 360 plus 45, but it looks the same. So I couldn't differentiate without the rotation being shown. So this is what number 2 kind of talks about. Draw the given angle in standard position and find the arrow representing the correct amount of rotation. So this is that rotation that we're showing. Find the measure of 2 other angles, and we want one positive and one negative coterminal with 52 degrees. Okay, so I'm just going to go ahead and start with 52 degrees. So I'm going to say that 52 degrees is here. And I'm going to find one positive coterminal angle that would look like 52 degrees. So I'm going to make that terminal side look the exact same. So these two should look like carbon copies of each other. The only difference is it's going to have one rotation shown. And this is going to be 52 plus 360 is 412 degrees. So that would be another coterminal angle. Now I'm going to go the other way and still draw that 52 degrees right there. But now I'm going to find a negative angle. So I'm going to start at the initial side and go around and find out what that is. So this time I'm going to take 52 minus 360 and I get negative 308 degrees. So that's how that works. Okay, now we're going to do some application problems here. And the first thing that I want to point out to you is that the disk makes 480 revolutions per minute. Okay, and you've probably seen this before in your car, the RPMs. That's what your engine's doing. And so what this means is it's going around 480 times every minute. So it says, through how many degrees will a point on the edge of the disk move in 2 seconds? So if it is going 480 revolutions in 1 minute, then I think the first thing I want to do is multiply that, sorry, not multiply it, divide it by 60, and that's going to get it in 1 second. So think about this. So there's 480 in 1 minute, so I'm going to divide that by 60, and that's going to give me how many revolutions in 1 second. Okay, so that's going to give me 8 revolutions every second, and we're dealing with 2 seconds. So I'm going to go ahead and multiply that by 2. So I'm talking about 16 revolutions in 2 seconds. Okay, so what does that mean? Have I answered my question? No, because it asked how many degrees. Well, remember, one time around the circle, so one revolution, that's equal to 360 degrees. So I'm doing that 16 times. So I'm going to multiply that by 16. So I'm going to take 16 times 360 and get 5,760, and that would be in degrees. Okay, so I want you to try these next 2 problems on your own, and it's just kind of applying the different things that we've learned. Okay, so in number 1, it's just asking how many revolutions per second. So it didn't ask how many degrees, so I could stop there. Number 2, the first thing that I did is I divided the clock, so an entire circle, by the numbers 12. So I knew that each number was 30 degrees of a circle. So I just multiplied that by 4 and got 120. Okay, and on this final one, you are switching back and forth from degrees, minutes, and seconds to decimal degrees, so go ahead and try that. Okay, so for number 3, let's talk about my thought process. So the first thing I noticed were that the 2 measurements that they gave us were in 2 different forms. So this one was in decimal degrees, and this one was in degrees, minutes, and seconds. So that kind of posed a problem for me. So what I decided to do is take the degrees, minutes, and seconds and turn it into decimal degrees, and then I subtracted the 2. So it says find the difference between these 2 measurements to the nearest minute, and to the nearest hundredth of a degree. Well, when I subtracted these, I got the decimal degree. So that's actually like the second part of it. But then I had to change this into degrees, minutes, and seconds. Well, there's 0 degrees there. And so I just took this 0.25 and multiplied it times 60, and I got 15 degrees. And so I think that answers my question, to the nearest minute. So my answer is 15 degrees. And that concludes lesson 1.